Humans have been fascinated with space since we first gazed towards the heavens, but it wasn't until the 20th century that scientists could realistically entertain the idea of exploring space from space. In 1945, the U.S. government established White Sands Proving Ground, or as it is known today, White Sands Missile Range, to conduct scientific research using captured German V-2 rockets. For many historians, July 9, 1945 marks the birth of the U.S. space program. At the same time White Sands Missile Range and the space age were being born, so was a small laboratory at New Mexico College of Agriculture and Mechanic Arts in Las Cruces, New Mexico. Created to support the Army's V-2 test program, the laboratory is now a noted aerospace R&D organization that performs contracts for NASA and all branches of the Department of Defense. Hello, I'm Harold Connell, and during the next hour I'll be your host for the Physical Science Laboratory, 50 Years of Excellence. In 1945, New Mexico College of Agriculture and Mechanic Arts was a small institution with only a few thousand students. However, A&M experienced a significant growth in enrollment as veterans returned from World War II. At this time, Dr. George W. Gardner was head of the physics department at New Mexico A&M. Sometime in late 1945, Dr. Gardner received a letter from an old schoolmate, Dr. Thomas Johnson, chief physicist at the Ballistics Research Laboratory, or BRL for short. Dr. Gardner's reply clearly demonstrates that BRL was interested in contracting with the college to provide support for V-2 testing at White Sands. The correspondence resulted eventually in a contract between New Mexico A&M and BRL to provide students and faculty for the purpose of reducing ballistic data on test of rockets and other missiles at White Sands Proving Ground, and to provide BRL data and other reports for the purpose of determining the ballistic characteristics of rockets and/or missiles. The contract's effective date was May 15, 1946. Initially, PSL's work at White Sands focused on supporting sounding rockets. These were launched by scientists to study various atmospheric phenomena and were not weapons related. The process of data reduction consisted of examining each frame of film and measuring the rocket's length, aspect angle, and distance from a center crosshair. These readings were tabulated by hand, along with the azimuth and elevation of the camera and elapsed time. By triangulating readings from 3 or more stations, range and altitude were plotted versus time on large sheets of graph paper, yielding trajectory curves showing altitude, range, and velocity versus elapsed time from liftoff. The contract with BRL was followed quickly by 2 others, one with the Applied Physics Laboratory of Johns Hopkins University through the Bureau of Ordnance, effective February 1947, although work was started November 26, 1946, and one with the Naval Research Laboratory effective sometime in January 1947. These contracts added many new types of work for New Mexico A&M, perhaps the most significant being field services to provide telemetry support. Until this time, New Mexico A&M had been performing its tasks of processing and reducing film in quarters on campus. Now it would actually field crews to White Sands. Although the agencies and their names have changed in the intervening years, PSL is still performing on successors to all 3 contracts. Telemetry literally means to measure from a distance. Telemetry systems are used to collect data from sensors placed aboard a test object, which in PSL's case is usually an aircraft, rocket, balloon, or missile. The sensors measure vehicle properties such as roll, pitch, altitude, and temperature, as well as data from scientific instruments. The telemetry system transmits this data to the ground, where it is recorded and used later by the scientists and engineers who initiated the test. Telemetry systems commonly consist of encoders, transmitters, antennas, receivers, and decoders. Soon after the BRL contract became effective, New Mexico A&M realized it would need an organizational entity to perform that work, as well as on the soon-to-be APL and NRL contracts. PSL was originally established as the Laboratory of Applied Sciences by New Mexico A&M's Board of Regents on September the 14th, 1946. Sometime between that date and January the 1st, 1947, the name was changed to the Physical Science Laboratory. By May 1947, the fledgling PSL had approximately 40, mostly full-time staff and a 3,500 square foot building of its own. By 1950, PSL was firmly established as the supplier for telemetry and data processing services for rockets launched at Wismar. However, as the versatility of rockets increased, more launches began occurring at locations other than Wismar. PSL's excellent reputation allowed capture of contracts to provide telemetry service at other ranges. Two particular events helped significantly to establish and maintain PSL's reputation: the International Geophysical Year, or IGY for short, and the U.S.'s race to beat the Russians to space. IGY was an 18-month international effort to investigate the world and its environment. More than 70 countries and 30,000 scientists participated in IGY. The first man-made satellite to ever orbit the Earth would be launched during IGY. For IGY, PSL sent field crews to Fort Churchill near Hudson's Bay in Canada, as well as other locations. But it was from the Fort Churchill range where nearly half of the IGY sounding rockets were launched. This effort lasted several years and included complete telemetry field services, ionosphere ground station support, photographic processing, rocket wiring, and telemetry data reduction. Although IGY was designated as being from July 1, 1957 through December 31, 1958, PSL actually began performing pre-IGY support as early as the autumn of 1956.
You kind of had to make sure that everything was going to work, because it was hard to take enough repair equipment to do the job. And there were several months, of course, went in to getting ready. Some of the racks would weigh about 200 pounds each. When they were put together, it would be 5 racks to make up a station. So we're talking about half a ton for one station, and there was 3 stations. We had to have equipment set up to where we not only tracked the rocket after it was launched, but we might run a half dozen, depending if we had a problem. We might run 8 or 10 tests while the rocket was laying in the assembly area. The rocket also went up in parts and pieces, and it would be completely assembled in a horizontal position. Our portion of it was the payload, what the experiment was going to collect. We would record this on film, which was 250 feet long and 9 inches wide, regular photographic film. And on the test, we would say maybe we'd run 50 feet on 4 5 different recorders, and we would have to process this film by hand. We would go through all 3 baths, the processing and then the wash bath, and so we would run in 4 men and would have an assembly line and process this film.